118 elements have been discovered so far. Right from the morning when you brush your teeth, to the soap you use, to the clothes you wear, to anything that you eat, everything is made up of these 118 elements, and that includes us also. We are mainly made up of oxygen, carbon, nitrogen, and hydrogen. The remaining elements are present in lesser quantities. Like 26 alphabets make up millions of libraries all over the world. These 118 elements make up millions of substances. So it's very important to organize these 118 elements well. This is where the modern periodic table comes into picture. It organizes these 118 elements in a very proper and systematic manner. Let's study some of their merits. The problem of isotopes is resolved in the modern periodic table. We know this was a problem in Mendeleev's periodic table because isotopes are elements having the same atomic number and different mass numbers. So in the modern periodic table, since hydrogen has 3 isotopes, hydrogen, protium, and deuterium, all 3 of them have atomic number 1. So this is the position that belongs to all the isotopes of hydrogen. So the positioning of isotopes in the modern periodic table is no longer a problem. Further, the position of element is now related to its electronic configuration, which is a very important property of elements. So let's see. So any element, say aluminium, if we know its electronic configuration, we know it has 3 shells, therefore it belongs to period 3. We know it has the number of valence electrons 3. That means it belongs to group 3A. So just by knowing the electronic configuration of the element, we know the exact positioning of the element in the modern periodic table. Also, the modern periodic table presents the element in a very systematic manner. So to study the existence and properties of the elements that have not been discovered yet, it's also very easy, since the elements in the periodic table are arranged in a very systematic manner. So we can even know the properties of the elements that are not yet discovered. The problem of isotopes was resolved in the modern periodic table. This is because the elements are arranged in the increasing order of. We know Moseley had placed the elements in increasing order of their atomic numbers. So since the elements are based on the increasing order of atomic numbers, so the problem of isotopes is resolved due to the placement of elements in increasing order of their atomic numbers and not their atomic masses, as was done by Mendeleev. There's still some problems in the modern periodic table that are not resolved. The positioning of hydrogen. Hydrogen is placed in group 1A. It shows properties similar to these elements, lithium, sodium, potassium, and so on. At the same time, it shows properties that are similar to these elements, that is, elements placed in group 7A, which we know are halogens. So the question as to whether hydrogen should be placed in group 1A or in 7A is not yet resolved. But for convenience, scientists put hydrogen in group 1A. Another problem with the modern periodic table is that it fails to accommodate the inner transition elements. We know that these inner transition elements lie behind these elements, lanthanum and actinum, but to see them in the two-dimensional frame, we had to put them separately in the periodic table. So the main body of the periodic table fails to accommodate the inner transition elements. So these are the problems with the modern periodic table that have not been able to be resolved today. Who knows, one day you might come up with a solution to these problems and form your own periodic table. Let's see.